Okay, I'll be honest, when I first saw this problem, I got stuck with it. There's no doubt about it. I kept looking at it, looking at it, looking at it, and it was tough to get through. All right. So let me just go through this and saying what I ended up using were what's called co-function identities. And one of the co-function identities I used was this one over here. I'll get to that. All right. And I also used what's known as simple properties of definite integrals. All right. So let's just start at the beginning. We're writing down something relatively simple, by the way. Right, like I know this thing integrates to pi over 2. How do I know that? The antiderivative of 1 is x, and I'm evaluating from 0 to pi over 2. What's that going to give you? Pi over 2. That's relatively simple. So if that's true, right, I'm going to get my eraser out. Eraser's business over here. I'll put a little check mark next to this over here. I'm going to say, this looks relatively simple to me, right? But then I said, is there another form of 1 that looks like what I'm looking at? And there is. It's this guy over here. This is another form of 1. Does it look like the original integration? It does. It looks just like it, right? It's going to be pi over 2. That integration produces pi over 2. And then I took that and I split it into 2 separate terms. Now, why is that? I want to look at things that I recognize over here. I definitely want to get this integration. I want to get it. But then I got this nightmare, right? But what I did there was I used a co-function identity. Let me go through that with you. Let me erase this business over here. So let's repeat what I got so far. That was easy to come up with. That was easy to come up with. This is easy to come up with. What I'm looking at, though, is I'm looking at this now, and this is my trouble. What's this thing? So what I used co-function identity. Let me write this down for you. That the cosine of x is the same thing as the sine of pi over 2 minus theta. These are what's called co-function identities, which means the cosine cubed of x would be, I'm cubing both sides, by the way, is the same thing as sine cubed pi over 2 minus theta. All right? So that's where this next line is coming from, right over here. Relatively simple. All right? By the way, I also use that identity on the bottom. All right? So, the sine cubed, let me write that down for you. I'm sorry, I should have the sine of x first. Is the same thing as a cosine. These are co-function identities. Pi over 2 minus theta. And so sine cubed is the same thing as cosine cubed pi over 2 minus theta. All right? Let me outline that for you. That's right over here. What do you get in the bottom? I could do the same identity again. So again, that cosine cubed, same thing as sine cubed. I got this over here. So I'm going to say, moving along, I'm certainly able to follow what's written down. All right? So I'm going to claim easy start, fairly easy to come up with that, fairly easy to get that. Using cofunction, fairly easy to look at that over there. Then what I do is I do a U substitution on this guy over here. Let me write down what the U substitution is, though. The U is equal to pi over 2 minus x. What does that mean? du is going to be minus dx. So I'm taking this integral here, and I'm going to put that U substitution in. And what do you get? You're going to get, well, let's see, pi over 2 to 0. That's coming from this over here. Let's see, you're going to get sine cubed let's see, pi over 2 minus x is u, right? You're going to get cosine cubed of u plus sine cubed of u. And what's dx? Oh, it's minus du. Now you should recognize that this thing is equivalent to this statement. Well, you can make another substitution. Go back to x's now. What are you going to get? 0 to pi over 2, making a very simple substitution right now, sine cubed of x over cosine cubed of x plus sine cubed of x dx. And that's where this line's coming from right over here. What do I got? Two identical integrals. Combine them together, divide both sides by 2, and you get your the value for that, which is pi over 4. Relatively simple. All right. I do see this as being a bit tricky. So I gotta be honest with you though, getting the antiderivative using Sage though really is not going to help you out. So if you use a computer algebra system, I don't think it's going to help you out. Will it be able to do the integration? It will be able to do it, but the bottom line is, I got to be honest with you, if you run to Sage to this problem over here, they'll give you the antiderivative, by the way. I just don't see it as being helpful in the problem, by the way. I do see this stuff over here being somewhat helpful. It's stuff you've learned in pre-calculus, by the way. So everything should make sense to you, although you may not understand why someone would try that. I'd be honest with you, I didn't try it initially. It took me a while to stumble on, co-function identities. It took me a while. All right? Now, if you go back to watching Black Pen, Red Pen, I really can't recall exactly what he did, but he said, this was sort of like a problem that pops up a lot, and you should just recognize it. And I'll be honest with you, I don't think I would recognize it. If I've seen it before, I just don't think I'd recognize it again and again. Having a co-function identity behind you and some persistence does pay off, though. Thank you.